These are solutions to one version of the quiz, and this version has all of the intercepts for both problems, so I'll try to be as thorough as possible. So in the first problem, we're finding the intercepts in the vertex of the function that is in general form. That's what we call this form. So the y-intercept is always found by plugging 0 in for x, so there's nothing special about quadratics here. That's just always how we find vertical intercepts of every function. And so if f of 0 is -5, that means that the point 0, -5 is on our graph. So that's done. The x-intercepts, to find the x-intercepts, we need the outputs to be 0. And so the formula for the outputs is this expression. And so I want that expression to equal 0. We learned that to solve a polynomial equation, I need to have the equation, all the stuff on one side and 0 on the other, and I have that. And then my next step would be to either factor this or use the quadratic formula. These numbers are very small, and so I feel like if it does factor, I should be able to see it. And in fact, there's only two factor pairs of -5. -5 is either 1 times -5 or -5 times 1. So there's only two things to try, and it turns out this one works fine. You could also use the quadratic formula for that. The product of these two things is equal to 0 if either of the two things is 0. So if either x plus 5 is 0 or x minus 1 is 0. And in the first case, that means x is -5. And in the second case, that means, let me not use a comma, let me write the word or, x equals 1. So the two x-intercepts are -5, 0, and 1, 0. So just real quick, while I've got those on there, I'll plot them. So that's 0, -5, that's -5, 0, and that's 1, 0. So I'm starting to fill in what this looks like. Now the vertex of the parabola happens at the x-coordinate minus b over 2a. And this, for this quadratic, the a is 1, the b is 4, and the c is -5. So those are the coefficients of this quadratic. So minus b over 2a would be -4 over 2 times 1, which is -2. So the vertex first coordinate is -2. The second coordinate of any point, once I know the first coordinate, is by just plugging the first coordinate into the formula. So f of -2 is -2 squared plus 4 times -2 minus 5. Notice my use of the parentheses. If I enter it just like that in my calculator, I'm sure that'll be right. And that is -13. Oops, not -13. Sorry, I don't know why I do anything in my head. 4 minus 8 minus 5. So it's -9. So -2, -9 is going to be the coordinate of the vertex. So that means my vertex is right down here. And so now I can kind of visualize how this looks. It goes down like that, comes back up like that. A few people actually plotted the symmetric point, which is a good idea. Right, the mirror image of this point is there. So anyway, so that's what it looks like. When the function is in vertex form, my approach to some of the algebra is different, but the meaning of everything is the same. So the y-intercept is, again, oops, it's called g, isn't it? My y-intercept I find by finding g of 0, so that's this expression, so that's -1/2. -1 squared is +1, so -1/2 plus 8, so that's 7.5. So 0, 7.5 is going to be my y-intercept. The x-intercepts are going to come from setting the formula for the outputs. So, and hopefully you're noticing that it's the same thing I'm doing in both cases. The algebra steps will be a little bit different depending on the form, but the again, the meaning of what I'm doing is the same each time. So I would have this equation. We saw that when we're trying to solve something like this, because this part is a perfect square, and that's where all the x's are, then my goal here is just to get that blue blob by itself on one side. And so I can do that by first subtracting 8 from both sides, and then multiplying both sides by -2. So if you do those two things, it'll say x minus 1 squared equals 16. And if you want to write out both of those steps, go ahead and do that and just see that that really is the same thing. From x minus 1 squared, we know that the square root of 16 is 4, so we know that 4 squared is 16, but then also minus 4 squared is 16. So if x minus 1 squared is 16, then x minus 1 has to be 4, or x minus 1 has to be -4, one or the other. So those are the only two numbers that you can square and get 16. In the first case, that means x equals 5. In the second case, it means x equals -3. So my two x-intercepts are 5, 0, or -3, 0. So again, I'll take a second to draw these. So there's 0, 7.5, 5, 0, and -3, 0. So starting to get the idea that maybe this parabola goes down. And if you remember what we said in class, that is indicated here by the fact that there's a -1/2 out in front. A negative number in front of the x squared term is always going to make your parabola open downwards, be what we call concave down. Okay, so the reason we like this form is because it's easy to identify the vertex from this form. So let me just rewrite it real quick to remind you of how, even if you've forgotten what the form is, how you can be sure you're right about the vertex. So the way we can think about the vertex here is look at the stuff inside the parentheses and ask yourself what value of x makes that equal to 0. The value of x that makes the red stuff equal to 0 is x equals 1. So the first coordinate of the vertex is 1. So x equals 1 makes this 0. It always is formed in the same way. So if you can remember the form, then you don't have to do that. But hopefully you can remember that, and then the form can't mess you up. As always, the y coordinate. Once we know the x coordinate is 1, the y coordinate is going to come from evaluating g of 1. But remember, 1 made the stuff in red 0, and so g of 1 has to be 8. It has to be what's left after all that stuff at the beginning is 0. So you can really evaluate, you can really plug it in and make sure that's right, but that is correct. So the vertex form highlights the role of the vertex. We can see the vertex there, but a lot of times people get confused about which one of those is a minus and which of them is a plus. And so this little trick, if you can remember the little trick, it will keep you straight. Okay, so 1, 8 is here. So that's the vertex, which means that is the high point of the graph. That's what the vertex does. It's either the high point or the low point. So our parabola is going to come up like this, turn over. The symmetric point that we like to draw is right there, and start coming down and go right through there. Like that. So that's our graph.